Here we have a SAT math problem. Okay, let's go to the question. 30 times r to the 16th power positive b times r to the 8th power positive 48. In the given expression, b is a positive integer. If p times r to the 8th power positive c is a factor of the expression where p and c are positive integers, what is the greatest possible value of b? Okay, here in the given expression, we have to get the greatest possible value of this b. Let me take the given expression as it is, that is 30 times r to the power of 16 positive b times r to the power of 8 positive 48 equals to 30 times, we can write this r to the power of 16 as r to the power of 8 whole to the power of 2. Here a power is raised to another power. Whenever a power is raised to another power, we can multiply the two exponents. When I multiply 8 and 2, I am getting 16. That is the simplification of this one is r to the power of 16. That's exactly where over here. Positive b times r to the 8th power positive 48. Okay, now in this expression, I find r to the 8th power over here and here. Let me assign a new variable for this r to the 8th power, that is let x equals to r to the power of 8. Then 30 times, we can plug in x for this r to the 8th power. We get 30 times x square, positive b times x, positive 48. Here I got a quadratic expression. Now let's consider the information we have over here. That is p times r to the power of 8 positive c is a factor of the given expression. And we have taken x equals to r to the 8th power. So we can replace this r to the 8th power by x. Then we get px positive c. When p times r to the power of 8 positive c is a factor of this expression, then px positive c is a factor of this quadratic expression over here. Let me write it. Px positive c, and also this p and c are positive integers. Clearly, this px positive c is one of the linear factors of this quadratic expression. So this quadratic expression is factorable. Now let me consider a quadratic expression in standard form, that is ax square positive bx positive c. And also I assume this quadratic expression is factorable. Then there is a formula to get the greatest possible value for the coefficient of x, that is b. So the formula is b less than or equal to, we have to multiply the coefficient of x square and the constant term ac and add 1 to it. So this is a formula to get the greatest possible value of b when the quadratic expression is given in standard form, and also it is factorable. That is, it can be factored into two linear factors. Now let's consider the quadratic expression we have over here. It is factorable because we have one of the linear factors over here. Now we can use this formula to get the greatest possible value of b over here. Okay, now let me write it. That is b less than or equal to, we have to multiply the coefficient of x square and the constant term, that is 30 times 48, and add 1, positive 1. Okay, here b less than or equal to, when I multiply 30 and 48, I am getting 1440, positive 1. B less than or equal to, when I add these two numbers, I am getting 1441. So the value of b can be 1441, otherwise it has to be less than 1441. Therefore, the greatest possible value of b is 1441.